Yes guys, so A part is also having 1.2. Why? Because probability of E when F has occurred first, so probability of E with respect to F is given by probability of E intersection F divided by probability of F. Now E intersection F, as I have just calculated here, is only one outcome, which is triple head is common out of these two, because E is having 4 outcomes, F is having these 2 outcomes, total outcomes. So H is common, HHT is not common, only one common. So this number of outcomes in E intersection F is 1. Okay, E intersection F is 1. So this is 1 here divided by PF, probability of F. In probability of F, in F, how many outcomes are there? Only 2. Total 2. So 1.2 is the answer. The first part A is done. Now let us take B part here. What does B part say? Let me take B part of this. Now B part says, B part here. Okay, so total outcomes should also be written. So solution we are finding out in which B part is there. What is B part? Again we have to find out probability of E when F has occurred. This we have to find out. What is given here in B part? In B part says, okay, now it says that at most 2 heads. B part says in the B part, yeah, E is at least 2 heads. E is at least 2 heads. At least 2 heads. And F is at least 2 heads are there. And F says in the second part, okay, and F is at least 1 tail. In the B part is at least 2 heads, and F says at most 2 heads. It says at most 2 heads. This is B part here. B, the 2 section of values of A, E and F are given. Okay, this is B part here. And C is E at most 2 tails, at most 2 tails, and F is at least 1 tail. Okay, that is C part. Only the third part there. Now in this case, so how many outcomes are there? Now E, this implies that E is having how many outcomes? Out of those 8 outcomes, so total 8 outcomes are there, one coin is tossed 3 times. Out of that, how many? At least 2 heads. At least means minimum 2 heads, 3 heads may be there. So how many those cases are there? At least 2 heads, that means 3 heads may be there maximum. Then at least 2 heads, so 2 heads must be there. So this is HHT, double head. There are 3 outcomes more. What is that? HTH, THH. So these 4 outcomes are there. At least 2 heads means minimum 2 heads, more may be there. This is at least. What is F here? F says at most 2 heads. It may be 0 heads, right? It may be 1 head, it may be 2 heads. At most means maximum 2 heads, not minimum. In at least means minimum 2 heads. More may be there. In this case, at most means maximum 2 heads, not more than that. So in this, F is having, in the E part, it was having at least 2 heads. At least means minimum 2 heads. It may be more also. The 3 heads we have taken, and 2 we have taken in E. Now in the F part we have at most 2 heads, maximum 2 heads. It may be 1 head also, it may be 0 head also. 0 head means tail. No heads, 0 head. Okay, now one head is there. That means HTT, THT, then TTH, 1 head only. Now at most 2 heads it says. So 2 heads, there are 3 more also. HHT, HTH and THH. These are the total 7 outcomes. 1, 2, 3, 4, 5, 6, 7. Out of 8, 7 outcomes are there in F. What is common here? This implies that E intersection F is equal to how much? Only these 3 outcomes are there. Why? Because these 3 are common. The HHH and TTT are not common. only three are there. Which are those? This is HHT, HTH, THH. These three outcomes are common. Alright. Therefore, n number of outcomes in E intersection F. This is E intersection F is equal to how much? 3 only. These three. 3 upon in F we were having 7 outcomes. So 3 upon 7 is the answer. What is the answer here? Therefore, probability of E when F has occurred is probability of E intersection F upon probability of F. Because F is having total 7 outcomes. This F is having 7 outcomes. So this is 7 in the denominator. Common is only 3. 3 upon 7. This is the answer here. Try to understand. Simple answer. This is the answer here. 3 upon 7 is the answer of this second part, B. Now C part, which is the last one of this question number 10. Let me take C part also. What does C part say? In the C part we have, what is E? In the C part, E says at most 2 heads. At most, what do they say? At most 2 tails, sorry. At most 2 tails. Alright, F says, what is the F? F event is, second event F. F is at least 1 tail. At least 1 tail. Try to understand this also. Now, therefore, E represents at most 2 tails. At most means maximum 2 tails. Minimum may be there. There may be no tails also. At most means maximum 2 tails. Not minimum, but maximum 2 tails. Not more than that. Okay. So 3 tails will not be there. It may be 0 tails. It may be 7 outcomes are there. But at most 2 tails means maximum 2 tails, not more than that. Means triple tails will not be there. So other 2 tails, 1 tail, 0 tails will be there. So this is H. Now let me take 2 tails, because at most 2 tails. 2 tails, or let me take first 1 tail. HTH, HHT, HHT, this is THH, this is 1 tail only. Now double tail also. This is TTH, THT, this is HTT, double tail. So 3 outcomes, double tail, 1 outcome, triple, 3 outcomes, 1 tail, 1 tail, there are 3 outcomes, double tail, 3 outcomes, and no tail. Okay, this is 1 tail, no tail, and 2 tails. At most 2 tails. So 7 outcomes are in E. What is F? At least 1 tail. It is at least 1 tail, means minimum 2 tails, 1 tail, it may be 2 or 3. So at least 1 tail is there. So 1 tail means this HTH, 1 tail, not less than that, maximum may be there. At least 1 tail, minimum 1 tail is there. So these 3 outcomes are there. T, okay, SHT and THH, 1 tail. 2 tails are also there. At least, sorry, it says at least 2 tails. So 1 tail, 2 tail, 3 tails. It may be there. So 2 tails are these 3 also. 7 outcomes are here also. What are 7 outcomes here? There are 2 tails. But at least 1 tail means 2 tails are also there. There are 2 tails. TH, TT, let me take this HTT, then THT, it may be TTH, and TTT. Triple tail is also possible. At least 1 tail. Minimum 1 tail, maximum may be there. So triple tails are there, 2 tails are there, 1 tail is there. At least 1 tail. Right? So 7 outcomes are here also. Here also 7 outcomes. But common. Therefore E intersection F. What is common here? In E intersection F, how many common are there? 6, I think. Because HSH, no common. TTT, no common. Others are common. 6 outcomes are there. These are 6 outcomes. Let me take N E intersection F is equal to 6. Which are those? All these other than HSH, TTT. triple T is not there, triple head are not there, others are there. So 6 outcomes are there. So this is equal to 6. Let me write directly. Number of outcomes in both of these which are common, and number of outcomes in E intersection F is 6, because triple H cancel out, triple T cancel out, others are 6 common. So 6 common. Right, so this is 6 intersection. Now, and F is 7 in the denominator. Therefore, probability of E, condition probability, therefore P probability of E when F has occurred first equal to 6 upon 7. Why? Because this is probability of E intersection F divided by probability of F. So this is how many outcomes were there? 6 common 6 upon 7 total. This is the answer here. This is the question number 10 completed. Okay. Let us take question number 11, which is the last one. Now question number 11, let us talk about the last question, 11th. What is given to us? Let me first read it and then solve it. Questions 11 says 2 coins are tossed once. 2 coins are tossed once. 2 coins are tossed once. That means 4 outcomes are there. Then find here. What is it? 2 coins are tossed once. Find probability of again E oblique F. Probability of E oblique F, or when F has occurred first in each of the following case. Sorry, this one. 2 coins are tossed once. Find E oblique F in each of the following. In each of the following. The same type of question, but what is given here? In each of the following. What are the following? Okay, E says tail appears on 1 coin. E says only. Okay, A and B parts are there. So this is A part. E says, in E part says, find probability of E oblique in each of the following. E is tail appears on 1 coin. On 1 coin. Try to understand this question. And F says, for the F here, F says 1 coin shows head. 1 coin shows head. Okay, so 2 coins can also be shown head. So one head is shown on 1 coin. Okay, so this is F here. And B part, let me take B. Now E says here, E no tail appears. No tail appears. And F in the second part, no tail appears and no head appears. It says no head appears. No head appears. This is very simple. Now first part says, let me take A part here, solution. Now solution, what is A part here? Now first outcomes are total 4, because 2 coins are tossed once, means 1 coin is tossed twice, maybe. So total 4 outcomes are there. What are the total 4 outcomes? Here, since S sample space, total sample space, HH, HT, TH and TT. Here are the total 4 outcomes. Out of this, in part A, let me take what is E here. Which parts are there? 1 coin shows, sorry, this tail appears on 1. Only one has having tail. HT and TH. Only one shows 1 tail. It says tail appears on 1 coin, not both. 1 coin only, so these 2 outcomes are there. With F here, F says 1 coin shows head. 1 coin shows head. It may be 2 heads also. So 1 HT, it may be TH, 1 coin shows head. It may be head also. Double head, it can be there. At least 1 head there, it is at least type. In F, 1 coin shows head. means on one coin there is head, it may be two coins also having. So this implies that E intersection F, or number of outcomes in E intersection F, which are common, only two, HT, TH, only two outcomes are there. This is two outcomes are common. So 2 upon F is having 3. What is the probability of this? Therefore, let me write here. Therefore, probability solution here. Probability E oblique F in part A, solution of part A is equal to probability of E intersection F upon probability of F. Now here E intersection F is 2. Okay, total common is 2, E intersection F, and F is 3. This is the first answer. Now B part, let me take B part here. This A part is completed. Now for B part, this B part, what is E here? Let me take the outcomes B. No tail appears. It means only head. There's only one outcome is there. Try to understand. And F says no head appears. What does it mean? Only tail. Nothing common. Intersection is null set. Therefore, in the second part B, here this implies that E intersection F is a null set, nothing common. That means 5 null set. Therefore, probability of E intersection F is 0. Right? Therefore, and F is having only one outcome. Therefore, probability of E when F has occurred first is equal to probability of E intersection F divided by probability of F. Try to understand, in this case nothing is common. So this is 0 upon 1. Because this is 1 here, one outcome F. F is having only TT, one outcome. 0 upon 1 is 0. This is the answer of second part of 11th question completed. This is how all these 11 questions have completed. How we have to calculate this condition probability. This is very illustrative examples here. Because intersection, we have to find out both intersection of them in the numerator, number of outcomes in that intersection divided by probability of the event which has appeared first. Okay, which has occurred first, that probability in the denominator. Then the answer we have to calculate. So these are total 11 questions we have completed. Okay, so this is how the process of condition probability is to be understood. What is condition probability? When the one event has happened first, then second is occurring. The probability of second event with respect to the first event which has occurred first, we have to find out that one condition probability, because condition is given. In all these cases, conditions are given because F is coming in the denominator. With respect to F, first intersection, we have to find out the numerator. Value is this. This is the definition of condition probability. What is condition probability? Definition. For example, E with respect to F, when F has appeared first, then E is occurring. So probability of E intersection F, number of outcomes in both E and F divided by number of outcomes in F only, whatever in the denominator. Okay, the event which has appeared first, that number is in the denominator. That is how we calculate this. Okay, so this shows the total completion of this whole lecture series, right? In this case, condition probability we are taking. The next lecture series, which is very important again, Bayes theorem. Try to understand. On the Bayes theorem, I will try to take 2 lecture series. For Bayes theorem is very, very important. Okay, that is also based on this condition probability also, because condition probability is just what you call explanation of condition probability in Bayes theorem. Bayes theorem is very important. Please try to understand that also. That is very much required. Okay. Now all these questions based on condition probability, they are appearing in almost all kinds of examinations. BTech, MTech, BSc, MSc, competitive examinations, 11th, 12th, all these examinations are there. Condition probability, what is Bayes theorem, what are the probability distribution, right? That binomial distribution. What is binomial distribution? We'll discuss about that also. But all these questions based on probability is very important almost for all the classes, 11, 12, BSc, MSc, MTech, BTech, engineering, competitive competitive examinations, right? All kinds of competitive examinations. They are giving this conditional probability, sometimes based on, I mean, some of them are giving, not almost all the competitive examinations, but the higher one, just like what you call examination for management aptitude test, right? Aptitude test. Management aptitude means CAT. In CAT exams, we can find conditional probability sometimes. Okay, so for management test, for engineering test also, IIT and G. Okay, for those students also we can find competitive examinations, all these kind of competitive examinations. I mean, these questions based on probability, okay, of higher level probability questions. They are appearing there. So all, I mean, so you have to just understand that what are the basics of conditional probability. Probability, how to calculate this. Then there are different techniques of finding the probability. Just like conditional probability is one of them, Bayes theorem is one of them, and theorems based on multiplication and addition theorems, they are very important. They are also techniques. Then combination, permutation formulae, they are also very important to find the calculation, how to solve the questions based on probability. Okay, so probability is a combination of different types of techniques. Those techniques, and this is one of them, conditional probability. And how condition is given, that I have explained here. Just try to understand these questions up to 11 question, part A and B. This is B part. A part we did this 2 by 3 answer was there. Here it is 0.1 is only 0 answer, because 0.1 is 0. Okay, so because in the second part nothing was common, because in there HS was there, only headed and tail, nothing is common between them, 0 common, null set by there. Okay, this is how the questions are completed. Okay, see you then in the next lecture series. Till then, bye, have a nice day. Okay, see you then, bye.